This is for Year 12 methods, and it's finding the values of a dilation for a set number of solutions. So we have this graph with a restricted domain from minus pi to 6 pi, and I have a cosine that's been squared multiplied by 2 plus 1, and I'm looking for when does it equal 1. So I've drawn it over here, and I can see that here it is, and when does it equal 1? Well, it equals 1 in this particular case twice. Once here and once here. So there's two particular occasions. However, I have the function which is f of kx. Therefore, x has been replaced with kx. Therefore, a dilation by a factor of 1 on k from the y-axis. So, I'm actually dilating in this direction. At the moment, I have two solutions. If I'm looking for only one solution, then I want to stretch this further that way so that this particular answer ends up over here and this one gets pushed out. So what I actually want is I've got 2 cos squared of kx on 4 plus 1 equals 1. And if I was to strip that back and move the 1 over, that would equal 0, and then divide by 2. I'm actually looking for the cos squared of theta equaling 0, which is the same as the cos of theta equaling 0. So what are all the values of the cos of theta that equals 0? I'm going to have values of minus pi on 2, pi on 2, 3 pi on 2, 5 pi on 2. Okay, if that is the case, that I only want one solution, and I want that solution to be 6 pi, then this kx on 4 has to equal pi on 2, and I actually want x to be 6 pi. So what I would like is this point here, that only one to be in the domain from minus pi to 6 pi, and I want x to be actually 6 pi. So my graph would end up looking like that, and this would be the only time. So k should equal, it's going to be k times 6 pi over 4 equals pi on 2. Therefore k is going to equal 4 pi on 12 pi. K is going to equal 1/3. So let's just double check that. If k equals 1/3, then this is going to be x on 12, and if I press X and open up a graphing window, and I take this and I drag and drop it, and I take this and I drag and drop it, and I take the 1 and drag and drop it, I get one solution. There's that solution. So to talk about that again, this is my angle. I want my one solution, therefore I want it to equal pi on 2, because if I put pi on 2 into here, I will get an answer of 0. So I want kx on 4 to equal pi on 2, and I want that answer to be at 6 pi. And that was the case, so only has one solution, that solution, therefore k equals 1/3. Part 2, find the solutions for k such that the equation has only got one solution, but it doesn't have to be at 6 pi. So if I move this over a little bit to the left, I'll still only have one solution. I could keep on moving a little bit more to the left and I'll still only have one solution. So what I'd like to do is I'd like to keep on moving it to the left until this answer here is at 6 pi. And when that answer there is at 6 pi, I'm actually going to then have two solutions. I don't want two solutions. So I want k bigger than 1/3 and equal to 1/3, because when it's 1/3 it's exactly one solution, but I need to find the bigger value of k. So what I'll do in this case is I will make this equal 3 pi on 2, because when it's 3 pi on 2 this comes into play and this gives me a second solution. So if I put 3 pi on 2 there, I'm going to have 3 pi on 2, therefore that's going to be 12 pi on 12, so k should equal 1. So I'll just double check that. So k equals 1, that means I'm going to have that as being 4. Execute, bring up my graph, drag and drop, and I get two solutions, one there and one here. So I want this to be less than 1, and that will give me two solutions. When it's exactly one solution, I don't wish to include the 1 because the 1 brings this factor, this solution, into play. Okay, find the values of k such that the equation this has exactly 3 solutions. Okay, if it's going to have 3 solutions, then when k equals 1, that gives me 2 solutions. So I wish to bring this one into play. So if k 6 pi on 4 equaled 5 pi on 2, therefore k equals 20 pi on 12, k equals 5/3. Let's have a little think as to what 5/3 would look like. If I put a 5 there, and thirds would give me a 12 on the bottom, and execute, open up my window, drag and drop, and drag and drop. I want to press execute. And I drag and drop, good, and get my 1. 1, 2, 3. Has this one come into play? So what I'd like to do is, if I make x equal minus pi, does that give me an answer of 1? And no, it doesn't. So that's 1.11. So therefore this one over here is not. So I've got 3 solutions. So when k equals 5/3, so 5/3, when it's equal to 5/3, I've got exactly 3. As k gets bigger, then this point here is going to get further to the left, but this one here will start coming in. So I'd like to know the value of k that means that this solution here at negative pi. Now this solution is the one that I have here. So what's the value of k so that this is a solution? So k times minus pi over 4 equals minus pi on 2. I'm using minus pi because in this position here I want that x value to be minus pi, but I want the whole angle to be minus pi on 2. So I've got k equals minus 4 pi on 2 pi minus k equals 2. So if I have k equals 2, I think that this is going to come into play. Therefore I'm going to have 1, 2, 3, 4 solutions when k equals 2. If k equals 2, that's going to be a 2 on the bottom, and that's going to be a 2 on the top, 4 on the bottom. Execute, bring up my graph, get rid of that, press XE, drag and drop, 1, 2, 3, 4 solutions. So 2 did bring this as being a 4th solution, and I could double check it by making sure that if I go given x equals minus pi, I get an answer of 1, which I do. Therefore I've got 1, 2, 3, 4 solutions, so I wish to less than 2 but not equal to 2, and they're all my solutions.